In lesson 7.2, we're going to be working on renaming mixed numbers and fractions. We're going to start off with our whiteboard, a whiteboard marker, and we'll eventually get to our math journal. So, would you please number 1 to 2 on your whiteboard? And you are going to decide if each number sentence is true or false. True or false. Remember, when you multiply any number times 1, you end up with that same number, correct? So if I take 7 times 1, I get 7, right? So if I multiply by a number less than 1, I'm going to get a smaller number. So if I take 1/2 times 3, would that be greater than 3? True or false? Number 2, if I take 5/6 times 3/4, would that be less than 3/4? True or false for each one of those? Number 1, I'm multiplying by a number less than 1 because 1 times 3 would be equal to 3. So if I'm multiplying by less than 1/2, it definitely cannot be greater than. So that would be false. 5/6 times 3/4. Can that be less than 3/4? That is true. Multiplying by a number less than 1. So if I were multiplying by 1 times 3/4, I would get 3/4, but I'm multiplying by less than that. So our answer would have to be less than. So that is true. How about 8/8 plus 12/12? Would that equal 8/8? Think about what 8/8 is equal to. 1 whole. 12/12, what is it equal to? 1 whole. What is 8/8 equal to? 1 whole. Is 1 times 1, 1? That is true. We're actually going to jump right into our math journal. Earlier than I thought, page 237. Go ahead and open to journal page 237. At the top it says renaming mixed numbers and fractions. Fractions greater than 1 can be written in many ways. If that red circle is worth 1, what is 3 circles plus 5 out of 6 worth? Well, this is worth 1 whole, 2, 3, and this is 5 out of 6 equal parts. We can call that 3 and 5, 6, which is the same as saying 3 wholes plus 5 sixths more. I also could name that fraction 23/6. I could take these 3 and divide them into 6. Shade those all in because the whole circle is filled. If I counted that all up, I would get 23/6. There's 6 6 here, plus 6 6, plus 6 6. 18 plus 5 is 23/6. Let's take a look at the bottom of the page. It says, write the following mixed numbers as fractions. You may use your fraction circle pieces or the fraction number line poster to help you. So you have a poster in the back of your math journal. Let's see. It is in the very back inside cover. It says fraction number lines poster. And I just inserted it so you can use that. I'm going to show you a couple of different ways to go about figuring these out. Again, multiple ways to do this. It says write the following mixed numbers as fractions. Again, you have your number line down there, but we can take 1 2/3 and we'll say, okay, that's divided into thirds. So let's take 1 whole circle and let's divide into thirds. And it says the whole thing. So we have 1 whole circle plus 2/3 of another one. How many thirds would that be altogether? 1, 2, 3, 4, 5. 5/3. Going across, number 2, it says divided into fifths. 1, 2 whole, plus 3/5 of another one. So I could say, let's take and divide those other ones into fifths. This shows me there's 2 whole circles shaded in, and then 3/5 of another one. How many would that be altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 in each circle is in fifths. 13/5. Now, that's probably not the most efficient way to do that. Let me show you another way. We could take 5 whole circles. We know that those circles are all in fourths because that's what my denominator tells me. So I can take 4/4. Here's another whole one, another whole circle, another whole circle, another whole circle, 4/4. Here's one whole circle, one whole, oh, sorry. Let me do that again. Here's 1, 2, 3, 4, 5 full circles for the 5, and then 3/4 more. Now all we have to do is add those top numbers together. 4 plus 4 plus 4 plus 4 plus 4. 4 times 5 is 20, plus 3 more is 23/4. Did you notice all I had to do is I just had to multiply my denominator times how many whole circles there were. There were 5 of them. So all I had to do was take 5 times 4 times 5 and then add in 3 more at the very end. So I'm going to do the same thing for number 4. I'm going to say that there are fifths, right? 6 of them. 1, 2, 3, 4, 5, 6 whole circles that are filled in with fifths and 1/5 more. So if I just take 1, 2, 3, 4, 5, 6, 6/5, so 6 times 5 is 30, plus 1 more is 31/5. So instead of having to draw out those pictures like I did in number 1 and number 2, I can think, hey, I took the number in the denominator and multiplied by the whole number, how many holes there were, and then added in the remaining. So that's what I'm going to do for number 5. I'm going to take the denominator, they're in eighths, times 4 wholes, so 8 times 4 is 32, and then I have 7 more to add in, plus 7. What's 32 plus 7? 39, and my eighths remain the same. And number 5, 3 6/4. Again, I'm going to take the denominator. It's in 4 equal parts, and there's 3 of them. 3 full circles that are in fours. So 3 times 4 equals 12 whole sections plus 6 more. And the reason I'm not multiplying by 6 is because there's just 6 more in the next circle. So 12 plus 6 is 18/4. 18/4. So you can draw a picture, or you could use multiplication and addition. Now we're going to go ahead and take, I'm going to move this, hang on. Now it says write the following fractions as whole numbers or mixed numbers with the greatest whole number possible. You may use your fraction circle pieces or the fraction number line poster to help you. We can just divide. How many 3s are there in 7? There's 2 of them. 3 times 2 is 6. I'm going to write my remainder on the top and my divisor doesn't change. So 7/3 is the same as 2 1/3. Number 8, how many ones are there in 2? There's 2, and it divides evenly. So 2 over 1 is the same thing as 2 whole. Number 9, 18/4. It just means how many 4s are there in 18? 4 times 4 would give me 16. Go ahead and subtract. The remainder goes on top. My divisor does not change. 4, my remainder is 2. My divisor stays the same. So 18/4 is the same as 4 2/4. Number 10, how many 3s are there in 9? That's all that means is divide. And it goes in there exactly 3 times. Number 11, how many 5s are there in 22? How many times does 5 go into 22? Goes in there 4 times. 5 times 4 is 20. My remainder goes on top, and my divisor never changes. 4 2/5. And lastly, how many 8s are there in 16? It goes in there twice.